We're going to start section 8.2, multiplying and dividing rational expressions. We're going to learn how to simplify rational expressions and multiply and divide them. You have one vocabulary word. All right, in lesson 8.1, that's what we just finished, you worked with inverse variation functions, like y equals 5 over x, where 5 would be k. The expression on the right side of this equation is called a rational expression. That side, the right side. A rational expression is a quotient, which is division, fraction, of two polynomials. Other examples of rational expressions include, okay, see how I have division or quotient of two polynomials, quotient of two polynomials, even though that's just a monomial, quotient of two polynomials. Because rational expressions are ratios of polynomials, you can simplify them the same way you simplified fractions. If you remember way back when, to write a fraction in simplest form, you can divide out the common factors in the numerator and the denominator. You do factors of 9, which means you split it up into the things that multiply together to get 9, 3 times 3. You split up 24 into things that multiply together to get 24, 8 times 3, and you cross off the things that are the same. Okay? When identifying values for which a rational expression is undefined, identify the values of the variable that make the original denominator equal to 0. Okay, we're going to talk about undefined expressions. So we want to look at where the denominator equals 0. If you have that in the denominator, x plus 5, the denominator is 0 when x equals negative 5. So that is where the equation would be undefined. So we would set x plus 5 equal to 0 and solve for x. Your equation is undefined at x equals negative 5. Let's do an example. Simplify. Identify any x values for which the expression is undefined. Okay, if we just look at the fraction, 10 over 6, we can, I'm going to rewrite this so I can write with it. We look at the greatest common factor of 10 and 6, which is 2. So I'm going to do 10 divided by 2, 6 divided by 2. So I just simplified the fraction into 5 over 3. Now I have x to the 8th over x to the 4th. So I have 8 x's on top, 4 on the bottom. That means it's 8 minus 4. I've got 5/3, and then I have x to the 8 minus 4. Okay, you can actually do the subtraction with these, 8 minus 4, or you can think I have 8 on the top, 4 on the bottom. So what I usually do is just cross that off and go like that, but whatever works for you. Where is it undefined? I don't have any variables in the denominator, so it's just undefined just at x equals 0. So if I plug 0 in for x, that means the whole expression is 0, so it's undefined at 0. Okay, it gets a little more complicated. Sorry, let me change my color of pen. Simplify, identify any let's go back one, I'm sorry. Okay, simplify, identify any x values for which the expression is undefined. Now when you have polynomials on top and bottom that are quadratic, that means we can factor the top and bottom. It's the ACB. Okay, I'm not going to do the ACB. If you need to do that to help you out, go for it. As you guys get higher and higher in math, you need to be able to factor them into two sets of parentheses just a little bit quicker. So on the top, ACB is negative 2. AC is negative 2, B is 1. So that gives me x plus 2 and x minus 1. So if I FOILed that, I get x squared minus x plus 2x minus 2, and I get the original one back. Okay, the denominator. A times c is negative 3, b is positive 2. So x minus 1, x plus 3. I can now cross off the things that match, and I'm left with x plus 2 over x plus 3. And we are undefined. We go back to the original. I'm undefined at x equals 1 and negative 3. Oops, spell it correctly. Okay, why don't you try this one? Okay, I rewrote it a little bit bigger so I could mess with it. We look at the numbers. The greatest common factor is 8. So 8 goes into 8 one time, 8 goes into 16 two times. Then you look at the variables. X squared, x to the 11th. I have 2 on the bottom, 11 on top. 11 minus 2 is 9. So I cross off the x squared, and the 11 goes to a 9. So I have my answer. Try another one. You have to factor the denominator. Okay, I factored the denominator. When there's an a term, doing a, c, and b works really well for me. As a refresher, you do a times c, which is negative 12, and b is 1. Negative 12 breaks up into negative 3 and 4. Negative 3 times 4 is negative 12. Negative 3 plus 4 is 1. Then you divide by factors of a. So I'm dividing by 3 times 1. Negative 3 divided by 3 is negative 1. 4 divided by 1 is 4. And then we just draw our arrows down. 3x plus 4, x minus 1, right there. Those go right there, and we cancel out the things that match. So I have 1 over x minus 1. Then you have to do what is undefined. You always go back to the original, which I did right there. X minus 1 is 0, so x equals 1 is undefined. And 3x plus 4 equals 0, so x equals negative 4/3 is undefined. So we need 2 answers here. One more. Factor the numerator and the denominator. Push pause again. There's a typo on this one. That right there should be a 6. Alright, so try again, which means this is going to be a 36. Alright, much easier to do this way. Push pause again, please. Okay, so I factored both the numerator and denominator, canceled out the things that were like, and then I took the entire denominator, set each set of parentheses equal to 0, and solved for x, and got where everything is undefined. This is a 2. Okay, sometimes it's easier to factor out a negative 1 too. So you're just going to have to recognize it, and with the practice of 1 or 2, you'll be able to. So simplify, identify any x values for which the expression is undefined. I take the numerator and the denominator and factor it. Okay, it always works for the x term to be first, so I'm going to go ahead and factor out a negative x. And that'll leave me with a negative 4 plus x, which is sort of silly to see. So I'm going to do negative x, x minus 4. See how that just flipped like that? Over your denominator, which is x minus 4, x plus 2, and then cancel out the two things that match. Your answer is negative x over x plus 2. Then you have to look for where it's undefined, and you always take the entire denominator. X is undefined at 4 and negative 2. Okay, you can try this one. Again, that numerator, you're going to want your x term to be first. So when you factor something out, you're going to have to factor out a negative. Push pause. And there you go. Try again. Push pause. There you go. Alright. You can multiply rational expressions by the same way that you multiply fractions. You want to factor all the numerators and the denominators completely. That means simplify it as much as you can. Divide out the common factors of the numerators and the denominators. Multiply the numerators, then multiply the denominators. That means straight across. If you have 1/2 times, 3/4, you multiply across, and you multiply across. Be sure the numerator and the denominator have no common factors other than 1. That means simplify as best you can. Alright, multiply. Assume that all expressions are defined. Okay, so we're going to look at the numerators and the denominators. First, I'm going to go top and bottom. Okay, the numbers are good. I can't simplify there, but let's look at the x's. I have 5 x's on top, 3 on the bottom. That means I'm going to cross off the 3 and reduce that to a 2. Now I have 3y's on top 3y's on top 7 on the bottom, so I'm going to cross off the 3 and reduce that 7 to a 4. Okay, then I'm going to take another set. The numbers are good, can't do anything there, but the letters, the variables, I have 2 x's on the bottom, 3 on top, so I'm going to cross off those 2, and I'm left with 1x on top. 4y's on top, 5y's on the bottom, I'm left with 1. I'm going to go ahead and rewrite it at this point because it's a little hard to read when you're writing these on your paper. You might want to leave enough room for simplifying. Sorry about that. Oh. Yikes. Sorry. Let's try that again. That's a 4. Multiply with 10 and a 9. I have 1x on top and 1y on bottom. Now let's look up and down crossways. I'm going to look this way and that way. 3 on top, 9 on the bottom. I can divide by 3. I can divide that by 2. And I can't simplify anymore. So now I multiply straight across. 1 times 5 is 5, x cubed. 1 times 3 is 3, y to the 5th. Let's try another one. Here I want to factor the numerator and denominator. I can factor out of 4. I'm left with x plus 5. Here I have x plus 3 and x minus 3. Now let's cancel some stuff. X plus 5's, x minus 3's, and that's it. Now I multiply straight across. I think the only thing on the numerator is a 1. On the denominator I have a 4 and an x plus 3. Alright guys, go ahead and try this one on your own and then come back and check your answers. And there's your answer. At this point you can push stop, and we're going to start the homework tomorrow, and you can go ahead and finish examples 4 and on tomorrow night. I didn't do 2 separate videos, so you can go ahead and push pause and start your homework. Or watch and not have to watch anything tomorrow night.